Okay, so which one of these things is stronger and why? Or why is it? Why is the diamond stronger than the graphite?
Because the way that its bond formed is like 3D and it's not 2D with both sides like.
And the graphite?
2D, so it's just like sheets of graphite.
Yeah. So we've got either, this is like a sheet, and this is a tetrahedral shape. Where there's stuff above, below, and on all the sides. So it's locked in place in a three-dimensional structure instead of just being locked in like a flat shape where the top and bottom could slide. So tell me about atoms becoming ions. What happens? That's it. Gain or lose electrons. One or more. Does an atom that has reacted no longer have the ability to react? So if it lost its electrons or gained its electrons, it's reacted already. Is it over for it? What happens now?
Just a new thing it can react. Or that it can. Its new form.
We just get different reactions. Reactions, not reactants. So we saw that video of the sodium going into the water, and the water exploded, right? We made sodium hydroxide, hydrogen gas, and a bunch of heat. What that sodium lost an electron. And so now it's a sodium with a missing electron. So that makes it a what? An ion. Now can that ion do stuff? We kind of sort of need it, right? What is it used for? Nerves, sure, nerve conduction. I need something to go across. How about my heart beating or something like that? Those are good. If I transfer sodium in or out of a cell, what happens to the water? Well, what happens to the water?
It transfers over.
It goes the opposite direction, right? So you can use an energy-intensive system to transfer sodium out of a cell, and you'll end up having water running with it. So what this allows you to do is change the salinity, change the water concentration, get something that's dehydrated to be not dehydrated, or the other way around. So know that reaction that has happened, that's done. That's over with. But that thing can still do stuff. Just because it's lost its electron doesn't mean that substance is no longer able to do things, because it can. Which one of these two things is more likely to gain an electron? What? Why is the bromine? That's right. Yeah, this is only needs one more electron, where the silicon needs 4 more electrons. I liken it to somebody who's got maybe like a little bit too high-strung collection of something. Like they've got every single Barbie doll ever made except for one. So what are they going to do?
They're gonna buy that Barbie doll.
Or they're going to get it somehow, right? They're going to be a little violent about getting it, as opposed to I still have a whole bunch of them to gather up. So it'll be a while. My nephews like the Lego men. And so they're like come in sets, right? And so there's like 10 in this set, and he's got 9. He needs the last one, and he's like, I must have this for my birthday. It's in 9 months, dude. I'm just letting you know that in 9 months I want this. Okay, but you'll probably have it before that. But if you don't, I'll definitely get that for you. So what is an ion?
Charged atom or molecule.
Okay. How about we go with charged particle. That way it can be an atom that's charged, or it could be a polyatomic ion that's charged. Cation, positive ion, and the anion, negative ion. All right, so why is lithium happy to form a compound with bromine? Wants to lose one electron. Wants to gain one electron. Yep. What's the lithium's charge before it reacts with the bromine? 0. It's an atom. Because it's got that one electron it wants to get rid of, right? And so after it reacts with it, what's its charge? Why is it positive? It gave away one of its 3 electrons, and it still has what? 3 protons, but now it's only got 2 electrons, so it's got a +1 overall charge. Same situation with the bromine. What's the charge before it reacts? 0. And then after? -1, because it's trying to get 1 electron. So now this bromine that's got 35 protons in it, now it has 36 electrons, and it just got that electron from that lithium. Does that make sense? All right, metals, nonmetals, how are those guys different from each other? Okay, so metals conduct heat and electricity. They have luster, shape. So malleable and ductile. They can form alloys. Give electrons. They like to give electrons away. Anything else? Mostly solids, yeah, we can throw that in there. Besides the 1. Anything else? So then we could say all that stuff opposite for the nonmetals. They're not lustrous, they don't conduct electricity or heat well, can't form alloys, they take electrons. They're mostly not solids. Okay.